Chem 20s. Mr. Riley here. We're going to do some gas stoichiometry. So those of you guys, if you're following along, we're going to look at question number 71 from your workbook and also question number 82. But yeah, if you don't have your workbook, you can still follow along and learn a few things. So we're going to look at two different types of gas stoichiometry questions. Now, when we're doing gas stoich, we need to recall a couple of things. This data will be in your data booklet as well. We need to know that at STP, okay, standard temperature and pressure, we have a molar volume of 22.4 liters per mole. Now that can get a little confusing because molar concentration is moles per liter, molar volume is liters per mole. How much liters of a gas per mole? You know, so it's going to look like this, 22.4 liters per mole. Now at standard ambient temperature and pressure, you're at 24.8 liters per mole, or you could write it like this, 24.8 liters per mole. And the other thing that you're going to need is potentially the ideal gas law, which, if you guys remember, is PV equals nRT. And you need that R value. For us, we use 8.314 kilopascal liters per mole Kelvin. Okay, you got all that so far? All right, so let's look at the first problem here. So this question says, assuming STP, how many liters of oxygen gas are needed to produce 19.8 liters of sulfur trioxide according to the equation below? So we need a balanced chemical equation. Work your equation out now. Pause the video. Pause it. Okay, this one's a little tough to balance, I think. Sulfur dioxide, SO2 gas, plus oxygen gas produces sulfur trioxide gas. Okay. So in this problem, balancing is a little bit tough. What I like to do is I have oxygen by itself here, just like a combustion reaction. I'm going to leave that till last. I'm going to see that, I have 4 oxygens on the left here, and I have 3 on the right. So I need to get this one on the right. I need to get this to an even number. So I'm going to put a 2 in front of here. That's going to give me 6 oxygens on the product side on the right. And now my sulfurs are messed up. So now I need 2 sulfurs over here. And so now I have 2 sulfurs, 2 sulfurs. I got 6 oxygens on my product side. And I have 4 plus 2 more on my reactant side. I'm good. Okay. So STP, we're going to be dealing with STP here. So I want to know how many liters of oxygen gas are needed to produce 19.8 liters of sulfur trioxide. So the only other information I have here is that this equation, or this chemical reaction, is happening at STP. So I'm going to use the molar volume as my conversion factor to help me to get to moles. And so I'm going to start with my given, which is my volume of SO3. So I have 19.8 liters of SO3. I'm going to convert that, okay, using my molar volume of any gas, any ideal gas, at STP. And so that's 22.4 liters per mole. So 22.4 liters for every mole of SO3. Okay. And so now I have moles of SO3. I want to jump over to moles of my required, which is oxygen. So there's 1 mole of oxygen for every 2 moles of SO3. And so now I'm going to be moving on to moles of oxygen, and now I need to get my moles of oxygen back into liters because I'm looking for volume. So I want liters, I have moles, okay, and we said this equation's happening at STP. So at STP, I have 22.4 liters per 1 mole. Now you might notice something interesting here, is that mathematically, your first step and your third step here cancel each other out. And this goes to something that we learned about in class called Avogadro's theory and the law of combining volumes. It's that for any chemical reaction that is involving only gases, we can use the molar ratio as a substitute for the volume ratio, because all gases at STP occupy the same volume, which is 22.4 liters. So really, all I have to do here is take 19.8 liters, times it by 1/2, or divide it by 2, and I'm going to get 9.90 liters. All right.